Hello ladies and gentlemen. We're going to do 13.3a today. We're going to be evaluating trig functions of any angle. Our objectives for today are to evaluate those trig functions by hand, and then we're going to use our reference angle and our reference triangle some more. So the first thing to remember is that the sine of theta is opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse, and the tangent of theta is the opposite over the adjacent. All right, and I'm going to give you a new way to think about this in just a little bit. I also want to go back and remind you of the information that I've said that you need to memorize. So here's our four quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? All right, so this is 0. This is 90, 180, this one is 270, and then all the way around is 360. I can also do this in radians, so let me get a different color pen, okay? So if I do this in radians, this is 0 radians, okay? Then this is pi over 2, this is pi, oops, can you see it? And then this guy down here is 3 pi over 2. So you need to memorize those radians. And then the first one I'm going to have is 30 degrees, and that is pi over 6 radians. Then I'm going to have 45 degrees, and that's going to be pi over 4 radians. And then the last one, I'm going to have 60 degrees, and that's going to be, oops, wrong color, oh well, and that's going to be pi over 3 radians. You have to have that information memorized, because now we're going to start using that information to help us manage our triangles. Okay? Another thing to remember.
Just so you know the times of things with breaks, dinners, breakfast, lunch.
Cool, thank you. Yeehaw. All right, the other one is your reference angle. We've talked about these, we found these. Okay, sorry about that. Getting ready to go to nerd camp. Woohoo! So our reference angle always sits on the x-axis, and this is one of the few times that always is a good math word. So it's always going to sit on the x-axis. Okay, and then my reference triangle is just going to be part of my reference angle. So you'll see kind of as we go along. All right, so I'm just going to start by doing some examples. Okay. All right, all of the directions are going to say, find the reference angle. And I'm going to do some additional labeling, because that's what's the information, sorry, that brain and mouth aren't working, that we're going to use as we get ready to start identifying things. Okay. All right, so the first one I have 2 pi over 3. So if you remember that pi over 3 is 60, okay, and then there's 2 of them, then that means it's 120 degrees. So that helps me to get my angle in the correct place while I learn kind of where my radians are. Okay, so 2 pi over 3 is going to be over here. This is 2 pi over 3. This is 120. That means this is 60. So the reference angle is going to be 60 degrees, or I'll write it over here, pi over 3. Okay, all right. And then what we're going to do is we're going to draw the triangle. It's a right triangle, okay? The reference angle is the pi over 3, but I'm going to go ahead and draw the reference triangle. Notice that it's sitting on the x-axis. My x is negative because I'm trying to get out to this end point out here. So x is negative because I'm going to the left, and y is positive because I'm going up, okay? All right, so my reference angle on this one is 60 degrees, or pi over 3. All right, the next example, I'm going to have 5 pi over 3. Again, pi over 3 is 60, and I expect you to have that memorized. 60 times 5 is going to be 300 degrees. Okay, so now I'm going to draw my diagram. I will expect you to draw these diagrams on every problem. Okay, so 300 degrees is all the way around, and it's 60 degrees shy of one full rotation. So that is my 300 degrees. Okay. My reference triangle is going to be sitting on the x-axis. My x is positive, my y is negative. Okay, so my reference angle is going to again be 60 degrees, and I'm just going to put 60 degrees because I don't really care if it's negative or not. All right. Okay, my next angle is going to be 3 pi over 4. Well, 3 pi over 4 is one of our specials, so if you'll remember that pi over 4 is 45 degrees, and there are 3 of them. And I'm actually not going to do the math because 45s are glorious because I can just count by 45s, okay? So if one quadrant is 90 degrees, that means there's 2 45s within each quadrant. So I'm going to have 3 pi over 4, so this is 1, 2, 3. Oops, that's a nice straight line. So this is 3 pi over 4. Okay, and so my reference angle is going to be 45 degrees or pi over 4. Okay, then if I draw my triangle again, okay, so there's the little 90. Again, I have a negative x and a positive y. The only reason that I'm adding that additional information is because I know what's coming next. So my reference angle on this one is going to be 45 degrees. I guess I should label that on this first one. It was 60 degrees. Okay, alrighty. So not a very difficult concept and really not much new other than starting to think about multiples of our special angles, okay? All right. So now I'm going to kind of give you some additional information about our quadrants, okay? I'm going to draw a little coordinate system again. So this is quadrant 1. Our quadrants always go in a counterclockwise rotation of 4. And let's think about a point in this particular quadrant. Doesn't matter where the point is, you'll notice that x is positive and y is positive. Okay, and remember, if this were my ordered pairs, I would have x, y. Okay, in the second quadrant, if I had a point, it would have a negative x and a positive y. Okay, and sometimes I write this negative, positive. Down here in the third quadrant, if I had a random point, I would have a negative x and a negative y, and so I think about this as negative and negative. And then in the fourth quadrant, I would have a positive x and a negative y, and I would write this as positive, negative. That information you need to know because it's going to help us as we manage our angles. So now I'm going to change kind of some of our notation. Previously, we have said that the sine of an angle is the opposite over the hypotenuse. Okay? So I'm going to draw an angle in the first quadrant just because. Okay, so this is my x distance, this is my y distance, and for right now I'm going to call this the hypotenuse. We will change the hypotenuse's name later. So if I do the sine of that angle, now I have the opposite is y, and then it's going to be over h. This is going to be our new ratio for sine. Okay, so if you forget, I can still get there by doing opposite over the hypotenuse, but now we're going to start thinking about opposite and adjacent in terms of y and x. Okay, so then the cosine of that angle is going to be the adjacent x over the hypotenuse, and the tangent of theta is going to be the opposite over the adjacent. So these are the new ratios, and I'm going to change them one more time by the time our chapter is over, but this is the way I need you to start thinking about sine, cosine, tangent. This always works if your reference triangle is sitting on the x-axis. If you chose very badly to do math up here, then the ratios aren't the same. So you have to do your ratios with your reference triangle sitting on the x-axis. All right, so now let's do a couple more examples. Okay, so I'm going to say sketch the angle. Sorry, and then label the reference triangle. Okay, so number one, or number A, letter A, I'm going to have 210 degrees. So 210 degrees is 180 plus 30. So I'm going to go 180 degrees. I'm going to add 30 degrees more. Okay, and this is my rotation. Notice I'm going to have a negative x and a negative y. And for right now, that's all I want you to label. And your reference angle is going to be 30 degrees. Okay? Then for b, I'm going to have a negative 260 degrees. Again, I always draw these angles every single time. So negative 260 is a negative 180 plus 80 degrees more. So there's the 80 degrees more. So there's the 180 plus 80. Notice I'm rotating across the bottom. So this is my negative 260. I'm going to draw my little right triangle. My x value would be negative and my y value would be positive. So my reference angle is going to be 80 degrees. Okay? And again, you really don't have to label the triangles with the coordinates, but I'm doing it now because we're going to need them in the next couple of problems. Okay? And then C, this angle is 15 pi over 4. Again, it's super easy to locate 45-degree angles because all I have to do is count. There's 15 of them, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this is going to be my angle. So I went all the way around twice, almost twice. This is 45 degrees. If I draw my little triangle, my x is positive and my y is negative. So that gives me my reference angle. The reference angle is 45 degrees, or pi over 4. And then I also have my reference triangle. All right, so now let's start using some of that information to help us evaluate some trig functions. So now we want to evaluate our function without a calculator. And anytime you see that, sometimes it will say find exact coordinates. That's what it means. It means no calculator. It also means for me that you have to draw the diagram and you have to label the reference triangle. If you label your reference triangle every single time, I can guarantee you will make significantly less mistakes. All right, so the first problem is going to say evaluate the cosine of 150 degrees. No calculator. So the first thing I do is I draw 150 degrees. It is, sorry, squiggly line, 30 degrees shy of 180. So this is the 150 degree angle. I'm going to draw my reference triangle. So if this is 30, that means that angle is 60. Opposite the 60 is a negative radical 3. Opposite the 30 is 1. And then the hypotenuse is 2.
Can you help me with?
Not right now. I'm
Okay.
recording a video. When I'm done, yes. Okay. So if I want to do the cosine of the 150 degrees, I'm going to do the cosine of my reference triangle. So cosine is x over the hypotenuse. So I'll write that down. The cosine of the angle is x over the hypotenuse. So it's a negative radical 3 over 2. It's about that easy. All right, so there is our problem. Okay, we always do our math on the triangle that sits on the x-axis. Never, ever up here. Okay? Down here it's going to be nice and easy, and again you have to memorize your 30, 60, 90s. All right, let's do another one. Now I want to do the sine of 8 pi over 3. Well, I know that pi over 3 is a special. So I know that pi over 3 is 60 degrees times 8 is going to be 480 degrees. Okay? So it means I'm going to go all the way around the circle and then some. Okay? So I'm actually going to go all the way around the circle, 360, and then I'm going to go 120 more. So this is the 30, this is the 60, this is my reference angle. So I went all the way around and then 120 degrees more. I draw my triangle. Okay, so this is my 480. If this is 60, that means this angle is 30. Opposite the 30 is a 1. Opposite the 60 is a radical 3. The hypotenuse is 2. Because I'm on the left-hand side in the second quadrant, my x is negative. Okay? You always want to make sure you put your signs on your reference triangle so you make less mistakes. So the sine of 8 pi over 3, I'll write this down, 8 pi over 3 is going to be y over the hypotenuse, so it's radical 3 over 2. And that's its exact coordinate. So it's really kind of a simple process. The hardest part are the drawings. Okay? The next angle is going to be the tangent of pi over 6. Okay, so we draw our triangle. Pi over 6 is 30 degrees, so that means it's in the first quadrant, so this is pi over 6, or 30 degrees. So it means this angle is 30, this angle is 60. Opposite the 30 is 1, opposite the 60 is a radical 3, the hypotenuse is 2. The tangent of an angle is y over x, so my tangent of pi over 6 is going to be y over x. And remember, we talked about in this particular chapter, I'm okay if you do not rationalize your denominator. So I'm okay if you leave it with the radical in the denominator. All right, I have 2 more of these. So the next one, I'm going to do the tangent of a negative 3 pi over 4. And again, pi over 4s are glorious because all I have to do is count by 2's. So I'm going to go in the negative rotation, so I have 1, 2, 3. So a negative 3 pi over 4 is here. That means this angle is 45. Remember, I only do math on the triangle that sits on the x-axis. So this is a negative 1, this is a negative 1, and this is a radical 2. The tangent of an angle is y over x, so it's a negative 1 divided by a negative 1, so it's a positive 1. So our answer, the tangent of a negative 3 pi over 4, is a positive 1. Okay? So not so difficult. All right. Our last example is a little bit different. It'll actually be one of the first problems on your homework. This one says, given a point on the terminal side of an angle, I want you to evaluate the sine, the cosine, and the tangent. Alrighty? Okay, so you're going to be given a point, a negative 9, 12. Alright, so I'm going to plot that point first. On my coordinate system, x is negative, y is positive, so that means my angle is over here. Okay, so that point is a negative 9, 12. Well, it also means that the x distance is a negative 9. Remember, negative just shows direction. You can't really have a negative distance. This is 12, and I need to find the hypotenuse. And I can do that by the Pythagorean theorem. And I'm just going to tell you that it's 25, because it is a Pythagorean triple. Okay? All right, this is our theta. That's our reference angle. So I'm going to say the sine of theta is y over h. So it's going to be 12 over 25. That's an h. The cosine of theta is x over h. So it's going to be a negative 9 over 25. And then my tangent of theta is y over x. So it's going to be 12 over a negative 9. And I like to bring my negatives to the top just because it makes me a happier camper. Alrighty. And then I would need to reduce this. Sorry, so this is a negative 4/3, and that would be my tangent of theta. Okay? So pretty simple. First step usually in those is that you have to find the hypotenuse. Alright, so let me give you your problems. Alright, the first one says, given a point, so it's like the one we just did, on the terminal side of the angle, evaluate by hand
Patty Pastor, Pam Welker, please come see Miss
the
Randall in the
sine,
main office.
the
Pam
cosine, and the
Welker
tangent
Patty Pastor
of
to Miss
theta.
Randall in the main
Okay?
office. Thank
Alright,
you.
so the point that you're going to be given for A is a negative 6, 9, and the point that you're given for B is a 5, negative 12. Alright, second problem. It says to sketch the angle and then find the reference angle. And I might also encourage you to find the reference triangle, labeling all your pieces. So for A, your angle is a negative 100 degrees. B is 320 degrees, and then C is a negative 5 pi over 6. That's a degrees, by the way. All right, last problem. Says evaluate the function without a calculator. Alternative directions, it might say find the exact value, because exact means no rounding, no calculator. Okay. A, it's going to be the sine of 135 degrees, which means, remember, you also have to draw the diagram, draw and label, because that is your work, and that will be my expectation on every single problem. Okay? So A is the sine of 135 degrees. B is the cosine of 7 pi over 4. And C is going to be the tangent of a negative pi over 4. Alrighty, those are your 3 problems. Good luck with those, and we'll go over them in class tomorrow.